Hello, my name is Caroline Williams, and I'm taking Physics 201 this summer. A little bit about myself, because I forgot to introduce myself at the beginning of this course. I am a senior at Liberty University studying environmental biology and global studies, and I like penguins, dirt, donuts, fairly easygoing. And I'm taking this course this summer just to kind of lighten my load because science is hard. So I was looking through some physics news articles, and I found a very interesting one from the Scientific American Journal. And it discussed LHC physicists that unveiled a charming new particle. And when you unveil a charming new particle, you just have to click into the article. So I looked into it, and it said that the discovery could offer fresh insight into how the fundamental forces bind together subatomic particles. So this article was talking about this particle and how physicists used the Large Hadron Collider Beauty experiment at the CERN, which is the European Organization for Nuclear Research, and how they discovered this new heavy particle. And so the particle, known as Xi-CC++, is composed of three smaller elementary particles called quarks. So specifically, it has one lighter weight up quark that is found in protons and neutrons, and then it has two charm quarks, which are heavier and of a more exotic variety. And so the designation of the up and the charm are two of the 6 flavors that physicists use to assign to quarks based on the particles' varying masses and charges. So the standard model of particle physics explains not only Xi-CC++, but many other possible particles with various configurations of the 6 known flavors that they designated. So until now, the doubly charmed particles, like the Xi-CC++, eluded conclusive detection. So just by studying it and everything, they've been able to do more research and have more data that they've collected. So there's all particles that are made up of quarks, and any particle made up of quarks is called a hadron. So the world's largest and most powerful particle accelerator, the CERN's Large Hadron Collider, slams these particles together in search of new particles and interactions. Hadrons fall into 2 broad families. So there's the mesons, which are exotic particles with 1 quark and 1 antiquark, and then baryons, the particles that are composed of 3 quarks. So the new Xi-CC++ particle is a baryon. That's because it has a doubly charmed nature, even though it's almost 4 times heavier than other baryons, like protons and neutrons. And they're made up of entirely lighter quarks than heavier ones, which is also interesting. So they found a doubly heavy I'm going to start this sentence over again. They found a doubly heavy quark baryon, and it's of great interest, obviously, that will provide a unique tool to further probe quantum chromodynamics, which is the theory that describes the strong force and one of the 4 fundamental forces. So they're pretty excited about this, and they think that it's a lot easier to study because protons and neutrons all uniformly zip around one another at nearly the speed of light, and it's very difficult for them to observe at such speed. So the Xi-CC++ particle, the sole light quark, whips around at a high speed around a heavier, slower moving heavy quark pair, and it creates a situation easier for the physicists to investigate. So one of the spokespeople said it's analogous to a planetary system in which the light quark is akin to a planet orbiting a binary pair of massive stars. So it's very interesting, and they discussed the data they collected and how it was difficult to discover, but they looked for telltale distribution of daughter particles, including other baryons, and were able to create their information from all their research. And in 2002, actually, they discovered something that they found to be a similar particle, but it was just below the threshold of statistical significance, so it didn't catch on really until recently. So the detection, they said, of a heavy particle is obviously very interesting. They can look for more and learn exactly how often they are created in collisions, and very interesting stuff. So there's also a little picture I printed out that shows the mesons and the baryons, and of course like protons and neutrons and their interactions. So yeah,